Hello viewers, welcome to my YouTube channel. This is Dr. Leela on subject signals and systems and Python. Today is the fourth lecture. Let us have a recap of what we covered in the third lecture. So in the third lecture, we continued with the standard signals in the continuous time domain, rectangular, triangle, exponentially decreasing, sync and signum signals. And we also learned the standard signals in discrete time signal domain. Exponential signals, unit step signal, unit ramp, impulse, sinusoidal and rectangle signals. Today we shall see some basic operations on the signal. So the basic operations are performed on the two variables. So any signal will have an independent variable. Most of the time it is the time, and a dependent variable depending on the physical variable that we are interested in. So there are some operations performed on the dependent variable and some operations performed on the independent variable. So those operations performed on the dependent variable result in the amplitude transformation, and the operations performed on independent variable are time reversal, time scaling and time shifting. So let us take the first case of amplitude transformation. So they are amplitude scaling, addition of signals, multiplication of two or more signals, and in addition a relation between the step and impulse as the differentiation and step and ramp as the integration is also studied. So let us take the first case of amplitude scaling. So amplitude scaling either increases or decreases the magnitude of the signal. So let us take an example of x of t is equal to 5 into u of t, where u of t is a unit step signal. When it is multiplied by 5, it results in a step signal of strength 5, as shown in this figure 1. So at t is equal to 0, it changes from 0 to 5, and thereon it remains at 5. And if it is less than 1, it gets reduced, as in the case x of t is equal to 0.5 u of t. Then it is shown here. The u of t unit step function, its magnitude is reduced from 1 to 0.5. This is the amplitude scaling of step signal. So let us take the ramp signal. What is meant by amplitude scaling of the ramp signal? A unit ramp signal will have a slope of 1 for t, a straight line of slope 1, and for t greater than 0, and 0 for t less than 0. Suppose if you make the slope is equal to 2, then its amplitude gets scaled to 2. So this is going to be a ramp or a straight line with slope is equal to 2. So it can also be less than 1, as shown in this figure. So if it is a sinusoidal signal, so here I have considered an example of a sine of 2 pi f t. So for 3 amplitudes, values of a, 2, 4 and 6, the signal looks like this. So the below one is for amplitude 2, this is for amplitude 4 and this is for 6. So in all these cases, we have seen that the time is not changed, only the magnitude changes. Suppose if we have 2 or more signals and we want to perform some arithmetic operation on that, addition, subtraction or multiplication. So here I have taken an example of x of t is equal to t into u of t, that is one signal, and another signal which is t square into u of t. Here x of t itself is a product of two signals and y of t itself is a product of two signals. How they look? And the problem chosen is to find out these four signals, p of t, which is sum of the two signals x of t and y of t, and q of t, which is the difference of the second signal y of t from the first one, and r of t is the difference of first signal x of t with the second signal, and s of t is a product of the two signals. We have to find out all these four signals. So you consider this x of t. It is having two signals as product. One is t and the other one is u of t. We know that u of t is a unit step signal which exists for t greater than 0, which is shown in this second figure here, and t is a straight line passing through the origin, extending for both positive and negative values of t. So if we take the product of these two, at every instant you consider the value of the first signal t and the second signal u of t and take the product. For all values of t less than 0, we find that u of t is 0. Even though t is not 0, the product is going to be equal to 0. So the resultant signal x of t is 0 for t less than 0. For t greater than 0, both the signals exist and the product is going to be 1 multiplied by whatever the signal here is going to be the signal that is present here. So we will have a signal t into u of t given by this red graph, that is x3, which is t into u of t. Similarly, the second signal y of t is the product of t square and u of t. Here t square exists for both positive and negative values of t and it is given by this. And u of t is for t greater than 0, it is 1, for t less than 0, it is 0. So when we take the product of these two signals, for t less than 0, the product is 0 because u of t is 0. And it exists only, non-zero values exist only for t greater than 0 and the resultant signal will be as shown here. So this is the x of t and y of t. Now making use of this x of t and y of t, let us find out what is p of t, q of t, r of t and s of t. To do this, we shall make a tabular column. Since the signal exists only for t greater than 0, we shall take t in steps of some 5 to, say I have taken here from 5 to 100 and calculate x of t into u of t, so which is equal to, we know what is t into u of t means multiplied by 1, so that is going to be equal to this t only for this x of t, and y of t is t square into 1 and that is also given here. Say 5 square into 1 is 25, 10 square into 1 is 100 and we tabulate the x and y like this. So from this x and y, p is x of t plus y of t. So just add these two columns and write what is the value of p. Then we can plot p versus t to get the sum signal x of t plus y of t. And similarly, q is x minus y. So take this x and subtract y from x. So we get 5 minus 25 minus 20 and like this we calculate for all values of t and then plot q of t versus t to get the signal q of t. Next, r of t is y of t minus x of t. So subtract x from y. So 25 minus 5 is plus 20, 100 minus 10 is plus 90, like this doing the r. And s is the product of x and y. Take the product of x and y from these two columns and tabulate here. And next, when we plot the four solutions, we get the graph like this or the signal like this. So p of t is the sum of x of t and y of t. It is plotted between minus 4 to 10. And q of t is x of t minus y of t, r of t like this and s of t is like this. Suppose this has to be manually worked out. Here I have used a table which automatically calculates this. If it is to be manually worked out, then you can skip some of these middle values and calculate it for few values of t and then approximately by hand you can plot the graphs of p, q, r and s. Next, to find the relation between step and impulse signal. So to find the relation between step and impulse signal, so let us consider a signal like this, which is not instantaneous, u of t, which is not instantaneously rising from 0 to 1 at t is equal to 0. Instead, it takes certain time delta t to rise from 0 to 1. So from 0 to delta, it is a ramp signal. For the t greater than delta, it is 1 and for t less than 0, it is 0. So we can write the mathematical expression for this signal as u delta of t, let us call it as u delta of t, that is equal to 1 by delta into t. That is, this is a straight line with slope is equal to, from here to here it is what? Delta y divided by delta x. Delta y is 1 and delta x is delta. So slope into t. This is the ramp that is existing between 0 to delta. 0 less than t less than delta. And its value is 1 for t greater than 0. It is 0 for all other values of t. So if you take the differentiate this u delta of t, d by dt of u delta of t, in this region 0 to delta, when you differentiate it, we get it 1 by delta into d by dt of t, which is 1, and differentiation of these two will be equal to 0. So d by dt of u delta of t is equal to 1 over delta. So this can be represented as a pulse of width delta and height is equal to 1 over delta. Okay. So this in the limit as delta tends to 0, see here it approaches the unit step function as in the limit as delta tends to 0. So as delta tends to 0, u delta of t approaches u of t, and its derivative as delta tends to 0, it approaches 1. Okay, so the product 1 by delta and delta is equal to 1. The area enclosed by this pulse is equal to 1. So in the limit as delta tends to 0, this is going to be a line of infinitesimally small width of height 1, which represents an impulse signal. So in the limit as delta tends to 0, d by dt of u delta of t is an impulse signal. So the relation between step and impulse is, we can derive the impulse by differentiating the step signal. We can also get it in another way from the first principle of definition of derivatives. So we can start from this pulse. This is, let us call it as delta delta of t. This is a pulse of width delta, height 1 by delta, which can be obtained as sum of two step signals. One is u of t and the other one is u of t minus delta. So if you take u of t, it is a signal like this, starting from 0. For t greater than 0, it is 1. And u of t minus delta is a shifted step signal, shifted to the value 1. So u of t minus delta minus u of t minus delta is a step signal shifted to t is equal to delta and having magnitude minus 1. When we add these two, we get a pulse of width delta, and for the duration, let me take this strength as 1 by delta, not a unit step, it is 1 by delta. So 1 by delta u of t minus 1 by delta u of t minus delta is going to be the pulse like this. So if we take the limit as delta tends to 0 of this delta delta of t, then it is delta tends to 0 in the limit 1 by delta u of t minus u of t minus delta. This is from first principle, it is nothing but d by dt of u of t. So this is nothing but delta of t. So that is how the relation between the step and the impulse signals derived. Then relation between ramp and step signal. So we know that the ramp signal is defined as r of t is equal to t for t greater than 0 and 0 for t less than 0, and graphically it is represented like this. If you differentiate this ramp signal d by dt of r of t, for t greater than 0 it is going to be equal to 1 because it is d by dt of t, and for t less than 0 it is 0. So when we plot this, it is nothing but a unit step signal. So the relation between ramp and unit step signal is that we can obtain the unit step signal by differentiating the unit ramp signal. That's all for today. Thank you for watching. If you like this video, you like and share it with your friends, and don't forget to subscribe and download the link in the description box for downloading this video, and leave your comment in the comment box. See you next time.